let's flip the question for this last video. A lot of times I say, okay, you tell me the confidence level. You tell me what the sample is. You tell me how many people we sampled or how many things we sampled, and then I'll give you the margin of error. But what if we go backwards? What if we want a certain margin of error, right? What if I want to take a sample and have our margin of error be 5%? I want our sample to be within 5% probably of the actual value. That's what this video is all about. So if you do a little algebra, for anyone who loves algebra, you essentially are solving for n, getting the n by itself. As algebra is not important for this class, I did it for you. If we want a certain margin of error, the sample size needs to be at least this much. And that's just p hat times q hat times z star over the margin of error, and then square it. Something I do need to warn you for that margin of error, make sure it's in decimal form. Okay, don't write it as a percent unless you include the percent sign. But usually we'll be converting it to decimals. And then we always round up as well. That's also important. If we get that our sample size needs to be at least 105.3, for example, that means we need at least a sample size of 106. Rounding to the nearest number doesn't really make sense. At least 105 is not bigger than this number. We'd need at least 106. Okay? Well, let's use this and see how it looks. It's believed that 25% of adults over 50 never graduated high school. We wish to see if the same is true among 25 to 30-year-olds. We're interested in the proportion of 25 to 30-year-olds who have never graduated high school. That's the proportion that we're interested in. So how many of this younger age group should we survey in order to estimate the proportion of non-graduates, again, or 25 to 30-year-olds to within 6%? With a 90% confidence level. We want our margin of error to be 6%. And we usually will write it as a decimal for the formula. Well, now this is great. Well, we just look at this. N should be at least p hat q hat times z star. What's our z star for a 90% confidence level? 1.645. All divided by the margin of error, which we said was 0.06. And we square that. Oh, wait a minute. What's p hat and q hat? Well, that'll be our sample proportion of 25 to 30-year-olds who never graduated high school. And this is the weird thing about this section. It's a little cyclical, a little circular, right? We need to figure out how many we need to ask, but the formula to decide how many need to ask depends on the result of our asking, right? We want to know how many people we need to ask, and the formula uses our sample. Find the sample size using our sample is a little weird. So what we do, we got like an inception moment. We now approximate, we don't actually write the second hat, but we're essentially approximating p hat and q hat now. We've gone another layer deeper because we don't know, we're not going to ever know p hat until we take the sample. Okay. So we're going to just guess, essentially. Statistically guess. Okay. So we're thinking the same might be true for this age group as it is for this age group. So we're going to use that other age group as a guess. Okay. And then we can find after the fact kind of how close we were. But for our initial sample, yeah, we'll guess with some kind of approximation. We'll say, okay, here, let's assume that p hat is 25%, which tells us that q hat will be about 75%. And then we can just plug everything in. So all of this is 0.25 times 0.75 times 1.645 over 0.06 squared. And we just type it into a calculator and see what we get. So let's do that. 0.25, 0.75, 1.645 over 0.06. Oops, I need those parentheses. Squared. Press enter and we get 140.93. It's about 140.9. Why am I not rounding? Why am I rounding so close? Why am I not including more decimals? Because we're going to round anyway. But the important thing is we always round up for sample size. We need to ask at least this many people. So how many must we survey? At least 141. Always round up. Individuals. And that's how we do it. And when we do that, as long as the proportion is close enough to what we expected, we'll have the right margin of error. If you wanted to be a little bit more sure, you could ask even more, but let's not go into that level of subtlety. And let's just kind of approach it this way with this approximation. Usually the homework questions and the quizzes will be pretty clear on what they want you to do. You're not going to have to be very creative with finding these p hats and q hats. Okay. And you can always let me know if you have questions about that specifically. So what if we wanted a smaller margin of error? Everything else is the same, but we wanted a smaller margin of error. Well, then what would be the sample size? Should it be bigger or smaller? If we want a smaller margin of error, we're going to need to ask more people. So it should be bigger. So we use almost the exact same formula. 0.25, still the same. 0.75, still the same. 1.645, same confidence level. The only thing that's different is the margin of error. It's now 4%. That's the only difference here. And again, this can also be a great result. Like maybe we did take a sample up here and our margin of error was too big. We wanted it, we decided we really wanted a 4% margin of error. Then we could really use the p hat and q hat. My neighbor's got his leaf blower again. We can really use that p hat and q hat from the previous sample to get a better approximation for the sample size. And that's fine. So we'll just type this into a calculator. Let's see what it is. And again, all that we have to change is 0.04. Make sure to press enter. Whoa, that's a lot bigger. It's about 317.1. So for a 6% margin of error, we only needed 141. But for a 4% margin of error, we need more than double that. And again, we're always rounding up. We need to be at least this value. All right. So we'll say at least 318 people. All right. And that's how you do it. And that's ends confidence intervals. That's everything you could possibly want to know about confidence intervals, unless there's more you want to know. And then, do I have a textbook for you? Okay. Or you can also ask me questions. One more. Again, this is basically the end, but just a subtle math comment for anyone who's curious. Why I'm writing an equal sign here instead of a greater than or equals to sign? Because math is a chain. So n needs to be at least this, but this is what we're really saying equals the thing after it. Okay? And that really shows up more when you do like more complicated proofs and analysis that we're not getting into. I don't really care for this class, but if you were curious, there it was. Let me know if you have any questions and have a good rest of your day, night, morning. Bye-bye.